presenting the big picture. So what does what we do fit into the larger community picture? So when you approach big topics and engaging the students in big topics around food or energy or transportation or housing or healthcare, you've got the skill and the knowledge going on the side, but you keep bringing their focus back to what's going to make the best community, what's going to build a stronger community, and what is my place in the community. So this greenhouse is that direct engagement in the community. It's the direct engagement in that bigger picture. From here and just the activities they do in here and the learning that goes on and what they understand about the fish and the plants and the bacteria and so forth, opens the door for studying healthcare and if there are more nutritious food. And it also opens the door for food security. Can everybody have equal access to that healthy food? It also speaks to transportation. Is it produced locally and does it go to your neighborhood as opposed to getting shipped out? How much energy is involved in the food production? We have to have food production. So then how do you do it more efficiently? Or what we say, how do you do it more sustainably? So by engaging in this growing practice, I think it really puts them in an arena to see a bigger picture because it's all connected. Everybody's all interconnected anyway. And I think society needs that well-rounded individual. And I think more and more people in their 20s and their 30s, even older, go back and say, what did I have a degree in? What did I choose to study in high school? And what do I do for a living? And when you take a look at those that are passionate about what they do for a living, it's simply the culmination of all those choices and classes and undertaking internships. And it ends up in a career that might not be exactly from where they started. It didn't deviate, it evolved. There's lots of different approaches to doing aquaponics and using aquaponics to teach students different subject areas, whether it's biology or chemistry or mathematics or something like that. The way I like to approach the aquaponics and what we do is just to build something really big and really cool and then just keep it there. So anytime you want to teach something, it's a reference. Does that make sense? So that's why it's so big and it produces so much food. It's kind of like it's real life. If that's the case, then what I want to talk about today is what I would consider a real life situation, for a full-scale aquaponics system. And I'm hoping that when we talk through some of the challenges or some of the observations we have right now, what we're going to go out to do today will take us in a direction of finding the answer to that question. So I'm going to pose a few questions, still do problem solving on how do you think we can figure out the answer to that question. So the focus then today is nutrient uptake. Nutrient uptake. So how do the plants in the greenhouse get their nutrients? What do we need to know in terms of nutrients and water and what the plants need? What do we need to know? Well, you started off saying, where does the nutrients and the water come from? Answer the question again. They're what? Fish food, right? So what do we need to know about the fish food? Bam! What's in it? What else do we need to know about fish food other than what's in it? What else? Okay, it could be how it's processed and so forth, but you're adding fish food. How much? Right, so you're going to go, well, a goodly amount.
The amount of how much fish you have in the tank.
There you go. So it also has to do with the population of the fish, because you just certainly don't want to overfeed the fish. Do you want to underfeed the fish?
No.
Why not?
They will die out.
Die out?
Starve.
Starve? What comes before that? What happens to anything that doesn't eat properly?
Systems shut down.
Yes, systems shut down. They won't
give the nutrients.
They won't get the nutrients, and what happens? What if somebody of your size, for example, all of a sudden gets a decrease in nutrients?
They like start losing weight rapidly.
Okay, start losing weight rapidly.
The brain doesn't function.
Very good. It's not just your organs that start to like have a negative response to it. You're flat out just not getting the same brain activity going, right? So, what do you think might impact the nutrient uptake of a plant? Right? So we have flow. Right? We're looking at the speed of the water, if you will. Right? The flow, we call it the flow rate. So if there's lots of nutrients in the water, but the water's moving really fast, it's almost like fast food, right? It's like those little roots are down there, and you're like just trying to get some fast food as it's like flying by. Anything else you can think of? Think of how the system is built. What else is in those plant beds that are going to encourage nutrient uptake? It's one of Zach's favorite words. He loves these things. Bubbles. What are all the bubbles?
Air.
What?
Air.
Air. Exactly. You've got to have O2. So today I want to focus on this. Flow rate. Let's see exactly how fast that water is moving through those systems. And the next time we meet, I'll share with you some of the research that's already happened on the optimum flow rate. What's the best speed of the water for maximum nutrient uptake? But today, let's just calculate what that is. All right? So, think of your system out there. If we're going to calculate flow rate, what info do we need to know? So today, before we got started today, Ponto got some stopwatches for us. We've got a 1 gallon bucket there. There's another 1 gallon bucket in the greenhouse. And then we have the yardsticks. And this is what we're going after today. We're going to go after flow rate, and we're going to go after volume. If both sides are the same, you can get a team on that bed and a team on this bed so you're not running into each other. All right? If you're working, you have to be very careful if you move around the greenhouse, all right? If you need to hang on to something, hang on to something. Because you've got to duck your head and get around the battery box. We have a propagation table. We don't want to crawl over that, so you have to kind of walk the long way. All right? So you're going to want to get 3 measurements on this bed, 3 measurements on that bed, 2 different teams. What are your measurements? You're going to use meters, or you're going to use feet, inches, meters? You're just going to bust out metric right away. You're just going to make it all confusing on us. All right. No, I like it. It just smells like science. Where are you going to put your meter sticks? All right, Vicelio. All right. I would prefer, that's why I'm asking, I prefer that you keep your tools, your measurements away from the plants. So if you're going to measure this length, please put your measuring tool on the deck. Let's say this is our beginning point. You have to measure in 3 different directions. Which directions do you measure in? Going this way? Going this way? That's right. That's right. Awesome. I have a feeling, I'll leave it up to you, this distance from here to here might be a little bit different than the distance from down there. And I'll tell you why later. And I'll check on you guys. You got
I want to be the lucky guy. I'm not bringing the bucket.
You can record time again.
All right.
Because
That's what Jack's doing.
yeah, but she's
Yeah.
Oh, you're waiting.
Fine.
Wait, so
you can write.
this one first. Which one first? The big one? Alright, so and then I'll do this one. Are you ready, Jackson? I am ready. Go.
Which grow bed is it?
This is the double. Alright, stop. 26.69.
That seems much more comfortable.
Okay, so
So
these
how,
are
I
in
see some
feet.
X's and O's on there.
Yeah, so these are what they are in feet. Oh wait, no.
Oh, is that your total
Actual
answer?
Oh no. So this is one.
Because that looks pretty good.
That's not our total answer. This is, I think, is that? Okay, so if we're trying to turn that into feet, what would it be?
So this is 12.6875 inches. That would be, it would be, you couldn't use 0.68 because that's too big. There would be 1 foot, but just a little tiny bit more than 1 foot. So you want to calculate it? Experiences adds to that. Adds to that pot of knowledge and those skills and that understanding. So the next step builds on this one. And we don't know. We don't know who's going to go into water sciences or food systems or healthcare. But I am convinced that whatever career they choose, they'll use all the skills and all the knowledge they've accumulated. And I think this is just a really important for them to learn at this age.
I enjoy just learning about a different way to do things, plant-wise, and I've learned a lot from it about different ways to do things. I enjoy about aquaponics is coming out and learning about the plants and how you can grow plants without using soil, and just coming out and seeing it with a couple of my friends, just learning how they grow.
I like the science of it, fish and the water and plants.